Okay. So yesterday we announced a gift for you, okay, a surprise gift, and I left you all guessing what that might be. And later that evening, I announced that we are going to give you the ABLOX platform for free. Yes? So what is actually the ABLOX platform? Has anyone any idea about the ABLOX platform? Why would you? Because that is really new. I don't think anyone would be having any idea because this platform is new and we are still working on it and it is ready and we are giving it to you for free because I want everyone to participate and learn. Okay. And but I just want one promise from you all. And what is that promise? That you all would be working on that platform and innovating new things. And whatever problem any one of you faces while making any projects in the ABLOX platform, you will make this as a community to share your problems and solve those problems. Okay? Yes? Am I clear to everyone? Come on, be active in the chat box. मुझे कैसे पता चलेगा आप लोग पार्टिसिपेट कर रहे हो कि नहीं कर रहे हो? Okay, okay. All right, all right. So, first of all, let me show you what ABLOX actually is. Hmm? Just give me a second. Okay, so is my screen visible to everyone? Mhm. Okay, yes. Okay, all right, all right. So, what I want to say is this is a platform where you can do your coding and make circuits using blocks. Basically, we designed it because in my experience, I have realized this that students find it difficult to write codes on their own. Yes, mostly what you do, you take it and copy paste it from Google or somewhere else because doing coding for younger students is very difficult. That is why they almost always copy the codes from the circuits, okay, or from anywhere else on Google Chrome or whatever they can find it on. But I want you to learn this exactly by yourself. I want you to learn and live this, okay? Yes. When you do certain tasks by yourself, only then you can learn how to perform these tasks and learn robotics in a more efficient way. So this is our ABLOX platform. And let me give you a small tutorial of how it works, what are the features, what you can do, and how is it better. Okay, so first of all, let me start with a very basic feature, and that is turn on and off an LED. All right. So if anyone of you wants to participate with me, they can access the website using ablocks.ableducation.com. Open your web browsers and in Google Chrome, you have to write ablocks, ABLOX dot ableducation.com. I'm copy pasting it in the chat box. Just give me 1 second. Wait, 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 wait. Uh, yes. Now let me show you how to turn on and off an LED in a very simple manner. So everyone knows about a loop. What is the loop? Yes, the recording for this meeting is will be most probably will be uploaded on YouTube. But for now, you should participate with me in this live class, and that is how you will learn. Okay. So this is one thing. So Vyom says, yes, he knows about loops. Okay. So the basic syntax for loop is for I equal to 0, I is less than equal to 5 or 10, and semicolon I plus plus or I minus minus. This is the basic syntax of a for loop. But you don't have to memorize it. You don't have to make it difficult or anything else because it is very simple. You just have to place and drag this block here and you are inside the loop. Okay, in Arduino Uno. Now, for say I want to turn on an LED. Now this is very, very simple. You just have to go inside Mecanzo outputs. Okay. Click on Mecanzo outputs. Go here. And what you have to select? LED. As simple as that. And now drag this block and place it inside the loop. Done. Was it difficult? No, it is very, very simple. You just have to see your LED would be connected to digital pin number 2. And now you can make it on, you can make it off. It's very simple. And now say suppose this is the logics block here. Okay. And this is the loops block, my blocks, and this is the variables. So you have multiple basic blocks here as well. You can add virtual delay. You can add, if you want to add delay, you can add delay as well. Okay. So now for say I want to turn off my LED, I just click here and done. My LED is now off. Now I have time. Say, if I want to introduce delay in my blocks, I have to just click on the time block and wait for, place it below this. Yes, I think a class 8th or ninth student who are doing STEM would be very efficient with this because they understand that inside void loop, we write digital write 4 comma high if you want to turn on something. Then we write delay and then we write digital write 4 comma low. But this is specifically made for students to understand coding in a much easier way. And you can also see that while you place the blocks here and there, on your right hand side of the screen, this is making the circuit for you. You don't have to make the circuit. This is making the circuit for you. And that is why this is so important and so efficient while learning. Now, next, what's next? Suppose now I turned on my LED and then I say that for 1 second, my LED should be on. Now, again, I go to LED or there is another, you can just click here and duplicate this. I duplicated it and placed it below the delay. And now I want my LED to turn off. And then again, I copy pasted this. I think some of you would remember to turn on and off an LED on, wait, off, wait. This is the simple logic on, wait, off, wait. So LED turns on, waits for 1 second, turns off, waits for 1 second, and then again turns on. Okay. Now say I want to run this loop 250 times. Now, do you know what the best part is? When you click on this play button right here, when you click on this play button, it will do the loop for you. It will run the loop for you. And as you can see in the, as you can see here, it is giving you each and every step. Waiting for 1 second, turning on LED, waiting for 1 second, turning off LED. It will give you exactly all the steps that are being executed while you run the code. Each and every step is being displayed for you. See, you are doing the coding by yourself. You get to understand the logic because it is explaining the logic to you through this comments. Okay. And you can even see this LED turning on and off again and again. It is making the circuit for you. You just have to place a few simple blocks here. So before I move ahead, I want to know if you understood this. I want everyone to respond with yes or no so that I can further explain or move ahead. Please write yes or no if you understood this concept. Okay. Okay. But I want answers from everyone. That is how I will I would understand that everyone is understanding because I'm here so that everyone who is participating should understand. Okay, once says, sir, please explain it again. Okay, it is very simple. Say, you once you understand what a loop is, right? Yes or no? Yes. Do you understand what a loop is? Okay. Okay, you know. Okay. So basically, a loop is used to, for those who don't know, a loop is used to repeat a statement again and again until a specific number of times or infinite times. So when I enter this loop, I have written loop runs 250 times in virtual circuit. That is, it will run 250 times. Now I took a simple block. Okay. Turn LED. And from where did I take this block? I just click on Mecanzo outputs and below in the list, I selected LED. Now I selected my LED and placed the block here. Yes, I just did that. It is very simple. Okay. So I just placed my blocks to turn on the LED. You also have options. You can connect it to any digital pin you want. See, as you can see, Arduino has 14 digital pins from 0 to 13 and Arduino has 6 analog pins from 0 to 5. You can connect it to any of the pins that you want. Suppose say I am connecting it to digital pin number 6. I select number 6. Now I want to turn on the LED or make the LED off. I have my choice. Suppose say I want the LED to be off first. Okay, so I click it on off. Now I wait for 1 second. If you want to increase the delay, you can increase the delay as well. Suppose say I say 2 seconds. And now after my LED has been off for 2 seconds, now I want to turn it on. So it should be the same pin number. Remember, it should be the same pin number. Now I select the pin number 6 and now I select it at on. And when I play this loop, you can easily see that my LED remains on for a few seconds and then turns off. 2 second cycle each. Okay. I hope you understood this. Now, please message again. Okay. Once you understood, all right. Now, let me show you how you can attach multiple LEDs as well. Suppose say I want to add another LED. So inside this, I select LED and connect my LED here. I say I use 3 LEDs. I connect this LED here. Now I have to select different pins because if I select a single pin, then all of the LEDs would be connected to the same pin. Suppose say one is connected to 6, another is connected to 7, and another is connected to 8. And now what I do is I wait for 2 seconds and all of these LEDs are on right now. Now I copy this command, turn LED, duplicate this command and place it below here. Again, duplicate this command and place it here. Now I just have to select the exact same pins that were before 6, 7 and 8. Students, can you see that there are 3 LEDs on you right now? You just have to play with the blocks and it is making the circuit for you. You don't have to worry about it. Now, firstly, all of my LEDs were on. Now, these LEDs should be off. So I select off here. And now when I play the loop, see, all of my LEDs are on and now off, on and off. So this is pretty simple and you can do it too. This is just an example. You can make a lot of those things that you want by your choice and how you want. Okay. So remember, moving forward, for say I go here, I stop this and suppose say I want to make a traffic light. Okay. So what should I do? I should take one LED, turn it on, keep it on for 7 or 10 seconds, whatever the red light is, then turn it off and then turn on the yellow LED for say about 5 seconds and then turn off the yellow LED and turn on the green LED for say about 5 seconds or so. So you can make a traffic light signal as well. So it is very simple for you to virtually display and virtually simulate all your circuits. And when you go here, suppose I go here, you can even see the code which is working behind your circuit. See, This is your struct RGB. This is your structure. We have taken three int variables. We have pin mode 6, pin mode 7, pin mode 8, void loop. And inside void loop, I wrote digital light 6 comma high, 7 comma high, 8 comma high. Then I wrote delay. And then I wrote digital light 6 comma low, 7 comma low, 8 comma low. If you are a younger student and you don't understand coding very well, you don't have to. You don't have to go into the background of the coding itself. You just have to focus on the circuit and focus on the steps. If you are a more experienced student, say you are in class 9th, 10th, or even 11th, 12th, and you want to learn coding or understand how the circuit is actually working. So this is the blocks by which the circuit works. This is the circuit on which your application is working. These are the lines what your code is executing. And if you want to see the actual code, just you have to click here and you can see the actual code behind your circuit. So how innovating is that? Say, suppose I want to use another thing. Okay. Is this clear to everyone? Please comment in the chat box. What I just explained, is it clear to everyone? Sir, in which language the coding is? Okay. The coding is usually in C++. You can use it in C++, C hash, Java. There are many ways to code, but usually for beginners, we use the C language. Okay. Okay, great. Suppose I should take another example. Maybe I should go inside DC motor. Okay, I take a DC motor. And now what should I do? I just place it inside this block. Done. That is all I have to do. Which motor? Motor 1. Direction forward. Speed, say, suppose I say 152. And now I play it. Okay, for code looking, you just have to, on the top, see there is a symbol, arrow slash arrow, this symbol. Just on the right side of the home button, you can see this code button. Okay, your motor is moving in the forward direction. And now when I click backwards, direction backward, your motor is moving in the opposite direction. Basically, you can simulate and you can see what your motor is doing, and you can simulate your blocks in a very simple manner. Okay, now let me delete this and move on to another. Okay, and you can even perform analog activities in this as well. Suppose I was giving you an example of your LED. So here is my LED. I had two options. First of all, I took it the digital way. Digital, and what is digital? On or off. There are only two options in digital. Either it's on, either it's off. But in analog electronics, you can select the brightness, the fading of an LED according to you. There are commands from 0 to 255. The lower the number, the lower the brightness. The higher the number, the higher will be the brightness. Suppose I connect my LED to digital pin number 9. Okay, my LED is connected to digital pin number 9. Now inside this, if I write 0, please look on your right hand side. You can see that the LED is off because 0 is off. Now suppose I write 25. I don't know if you're able to see it inside the LED, but the LED is glowing very dimly. Very dim, but the LED is glowing. I can see it. I don't know if you can see it. So let's say I increase the number. Say I write 50. Now can you see that the LED is glowing very slightly? Yes? Okay, let me further increase this. Say I write 100. Now I think you all can see the color. Yes? So 255 is the maximum and 0 is the minimum. So if I keep increasing this number, say suppose I write 125, the color will be more bright. The LED will glow more brightly. Suppose say I write 180, it is almost at its full peak. Suppose I write 255, that is the full brightness. So when I write 255, your LED is glowing at full brightness. Yes, do you understand this? Yes. Any questions so far? So this is the analog way on how to control your LEDs. All right. And now moving on, say I delete my LED and let's move on to something else. What do you want to do? Suppose let's do something display. Okay. LCD. This is my LCD. Okay. So inside the LCD, what you have to do, LCD is very complex, but this block thing makes it very simple. You just have to use two blocks. And what are the two blocks? First, you have to set up your LCD outside the loop. So your LCD has a memory where it stores the characters that you send to it. So you don't have to do anything. You just have to keep it the way it is, 0 cross 3F or 0 cross 27, whatever is the memory. If you're a senior student or a more experienced student, I think you already know what memory type is. And if you are a beginner student, I advise you not to go too much deep inside the type of memory. And I don't think it will affect much. Okay. So don't worry about it, keep it as it is. Size 16 cross 2. What is the size of the LCD? Are you using a bigger LCD that is 20 cross 4, or are you using a smaller one that is 16 cross 2? And your LCD has two pins, SDA and SCL. Okay, that is serial clock pins that are connected with the I2C module. You don't have to go into the background. I'm not going to explain you too much details to bore you out. I'm just explaining how in a very simple way you can understand how to interface an LCD. Okay, so first we set up the LCD, and secondly, I just have to place this block inside the loop. And now the easiest task in the world. Suppose say I write Aditya in the first row. In the second row, I write Vinod. Done. See how simple was that? And you can see that at the moment you write something on your LCD screen, it is being displayed on the right hand side immediately. Hmm? And when you run this as well, you can see step 1, step 2, step 3, printing message for 3 seconds, clearing the screen, delay in seconds. You can even change the delay. है ना? So you can see each and every message. See, it is telling you how your LCD is working. Printing message, clearing the screen, printing the message for 3 seconds, then again clearing the screen. So it has only two tasks. It prints your message and then clears up the screen. Say suppose I delete this message, and I write hello students. See, this will be displayed here. Done. So it is very easy to interface your LCD as well. And when you become a little more experienced, you can add two or more things at the same time and play with them. And you can see the code as well. You can see the circuit as well. So I think this is a very good opportunity for you to practice. And while you have this on your hands for free, I think you should practice on it and learn as much as you can. Okay, because these opportunities are very rare. And if you're given an opportunity, you should make full use of it. Am I right, students? Yes? Okay. See, students, I only have one requirement, and that requirement is that if I'm taking a session, so everyone should participate in the session. I should feel like everyone wants to learn, everyone wants to grow. Okay. So you should write yes or no. That is all I want, which basically means that if you're understanding what I'm trying to say or not. This makes me happy. All right. Good. Now I have another thing for you. Suppose, let's see, I delete this LCD here. Okay. And now I move on to suppose a servo motor. Even the servo motor is very easy to interface. You have this loop. Say inside the loop, I write that it should run for 100 times. And now I place this servo motor inside the servo motor code block inside the loop. And now my servo motor is connected to pin number 2. Let me show you. If I write 0 degrees here, your servo motor will be at 0 degree. Can you see that? And now for say I write 30. Suppose I write 30 here. Your servo motor will rotate by 30 degrees. And now I delete this and write 45. It will rotate by 45. I write 90. It is exactly 90 degrees. Suppose I write 135 degrees. It is 135 degrees exactly. Now I write 180. So it is exactly opposite to the 90-degree angle. Sorry, the 0-degree angle. It is exactly opposite to the 90-degree, 0-degree angle and perpendicular to the 90-degree angle. Now I write 270. This is 270. And now I write 360. So this is a full circle and your servo motor has come to the initial point from where it started. So this is how you can control a servo motor. I hope you are understanding what I'm trying to explain, that you just have to place small blocks and you don't have to go into the complexity of the background. You don't have to understand all the codes and everything. Later, when you are a bit pro, you can try understanding the codes and even you can share this with your friends. Okay. So for say I have Mecanzo inputs as well. Inputs means your sensors. So we have some basic sensors like the IR remote, joystick, pins, temperature, thermistor, touch, push button. Okay. For say I want to use my ultrasonic sensor. All right. So I click on the ultrasonic sensor and this says setup. So if you have already worked with ultrasonic sensor, you know that there are two pins, trigger pin and an echo pin. So I click on the trigger pin and say I connect my trigger pin to pin number 4 and my another pin to pin number 5, echo pin. And distance is, and whatever distance I write here, it will be displayed on right hand side of the screen. Okay. And later even you can make car parking sensors, add a buzzer to this project and write if. And where will you get if? Here, logic. Then if, then else. This is the logic. If I place this inside the loop, okay, and I create a variable, create a number variable named in the D. D is for distance. Okay, I create this variable. And now I write, for example, I write, say, I write, this is my loop, I place it here. And if I say if, now I have to create a variable. And this is the value 33 that is being stored inside D. But I have to check for the distance as well. So this is my block variables. I have created my variable and distance is in centimeters. So this is displaying my displaying my distance in centimeters. Okay. So now what I do is if I create logic and this is my block for logic, if this is happening, then this will happen, either not. Okay. So this is my loop number 1. And inside this, if I place it here, see, you can place the block here or else LED is equal to off. Say you want to turn on and off an LED. Okay. So what you do, go inside then LED and turn on LED to else. Inside else, you can place this. Basically, what I wanted to show you is that suppose your distance is greater than 30 centimeters, so your LED is off, that, or maybe your buzzer is off, your buzzer is not beeping because 30 centimeters is a safe distance. But say suppose you come very close to a wall, you are around 10 centimeters and you want your buzzer to beep. So you write if D, that is distance greater than 30 centimeter, buzzer will buzzer will be off. But if distance is less than 10 centimeter, your LED or buzzer will be on. So this is how you can make your simple projects in the beginning without using too much coding or without using too many numbers or complexity. See, this is all very easy. You don't even have to write the logic or the loop. It will automatically create it and write it for you inside the code. Here you have logics. Inside the logic, you have if then, if else, and some basic and if condition, else condition, and condition. Okay. Then you have some variables. You can create variables as well. Then you have your list, color, some math programming, some text, code, messages. Then you have your basic delay, and then we have Mecanzo output. That is your 7-segment delay, LCD, LED, LED matrix, RGB servo motor, and a few others. And then we have mechanical inputs such as thermistor, push button, ultrasonic sensor, touch button. So you can play around with these. And when you see, I want to tell you one thing. When you start creating new things, okay, when you start creating new things, when you start experiencing new things, you might find yourself in trouble. You might find yourself, oh, maybe I cannot do this. This is very difficult. When I started this project, when I started my journey here, I was also very confused about this. But slowly, I never gave up. I kept on learning. I kept on learning. And today I can say I'm good at it. But there are people who are even better than me. Why? Because they've been doing it for so many years. So this is called experience. The more you procreate, the more you understand, and the more the capacity that you have to learn and grow, the more you will outshine others. That is what I want to teach you. So this is a small gift from us, from our side to you, so that you can learn this, so you can understand, you can even practice. Because I believe that in many schools, you have your basic sensors and programming kits and whatnot. But when you go home, no kid has the access to these things. No kid has access to Arduino or this and that or basic electronic circuits. So we wanted to create something so that you can simulate these circuits sitting at your home. Learning should never stop. That is what we wanted to do. But I want to have two promises from you. Yes, please say yes or no. Are you willing to share? Are you willing to keep your two promises? Okay, great. So first of all, today, everyone please take screenshots from today's session, and if possible, you have to share it on your social media handles. Okay, whatever, be it WhatsApp, or if anyone uses YouTube or Instagram, I don't know what that is. But last May, we will have a small photo session. Take it from your phone. I will tell you when you can, and you can take it from your phones or laptops or take a screenshot and post it about this ABLOX content. So this is one thing that I wanted a promise from you all, and tag us ABL_education if you're posting it on Instagram. Secondly, my second promise that I wanted from you all was that you should share your success, share your achievements on the groups, right? You are added in the B1, B2, B3, B4 groups. So I believe that sometimes those groups are very quiet. And I want you to create those four groups as a community, to question, to arouse knowledge, to participate, learn, and grow. Yes, I want all of you to make new projects, to innovate something new. And if you're getting stuck somewhere, tell this thing to your colleagues in the B1, B2, B3, B4 batches. Tell this to your colleagues, share a screenshot, write your problem. And I'm sure that there are over 100 participants in each group. Some student or the other would have made a similar project in real life or in virtual environment, and he would be able to help you. So I want you to create a community. I want you to help each other out so that you all can grow together. Because because when you grow together, you grow better. You are able to stand, you are able to support each other. Yes, am I right? So that is what I want from all of you. I want you to support each other and grow together. Whatever problems you are having, share it in the group. Maybe any of the sir will help you, or even the students can help you. But I want to create an environment of learning, interaction, growth. Okay, so this is the second promise that I want from all of you. Would you do it? Yes. Okay. Someone is asking, how did you create this variable? Variable creation is very easy. You just have to click on variables. Okay. So you have four options: create a number variable, text variable, Boolean variable, color variable. Suppose I want to create a Boolean variable. So my name is, uh, suppose I name this variable bol, BOL. Okay. And I write okay. So this Boolean variable is a variable that accepts only two conditions, that is true and false. So either my Boolean variable can be true or it can be false. So this is how you create a variable. And in fact, this is just a small tutorial. When you start doing things, you will understand this platform better. So this is the second promise that I want from all of you. Keep learning, doing small projects all this while, and learn small bits, tips, and tricks from anywhere you want. You can even see, we are all there for you. Why? Because we have our YouTube channel, we have ABL Education. Okay. So, secondly, if you haven't subscribed to the ABL channel, you should, because we have posted videos there. Just give me 1 second and then I will show you a few videos of the ABL ABLOX video series. Just give me 2 seconds. Let me open this. Here we have playlists and okay, let me share my screen. Visible to everyone? So here you can see multiple playlist. If you see, we are doing so much for you. YouTube is totally free and charges nothing. All we expect from you, all we want in return is that you subscribe us. Okay, give us some recognition for the work we do. That is all we want. We want you to support us. Okay, that is all we want. So we make videos for you. If you want to learn data science, this is the video for you. Data science for class ninth, this is all for you free of cost. STEM A blocks, you want to learn STEM on the A blocks platform, this is for you. Scratch classes, artificial intelligence, STEM, Python class 9, Mecanzo 11, Arduino class 9. We have so much content for you. You can learn anything that you want. Everything is available here. Okay, for say I open this STEM. So we have a few videos uploaded here. Suppose you want to learn how to interface an RGB LED. We have a whole PPT prepared. As you can see, we have a whole PPT prepared of how you can interface an RGB LED with Arduino Uno on the ABLOX platform. Then another, we have a dot matrix LED as well. If you want to learn that RGB LED rainbow. So we have multiple videos here, which you can learn and understand. Okay. So I hope this session was beneficial for you. Okay, I'm sharing with you some details. I have already shared with you the ABLOX platform where you can learn. Okay, and my second promise was, as I've already told you, to make this a community, interact with each other. All right, and please keep practicing on your ABLOX platform. All right. So these are the two promises that I wanted from you just in return. That is just if you're using the ABLOX platform, take a screenshot and tag us on Instagram if you want. And please tell your friends to subscribe us on YouTube. And this is the first promise. And the second one is make it a creative hub and community and learn and post your problems and solutions on the groups. Don't let them be inactive. Okay. So these are the only two promises that I have. Congratulations on your gift. So you have your ABLOX platform. I have given you the website, the link, and feel free to use it whenever you want. And share your success stories, share your small achievements, be it big or small. You should share it with us. Okay. If you're winning a competition in a school, share it with us. We would be more than proud and happy to share it on our Instagram page. Even if you're winning something big or small, if you're going into a robotics competition, if you're winning something, show it to your friends. All right. Share it on the group, show it to your friends and share it with us. We will definitely post it on our social media handle because we are proud of you. We believe in you and we want to share your success as our success. Okay. So that is what I wanted to tell you. This is your ABLOX platform. And any doubts, you can you can tell me here in the chat box if you have any doubts. Okay. So before this session ends, I want everyone to please turn on their cameras so that I can take a picture with you. It has been a while. I think I met most of you back in December, right? While we were in Bombay. So it has already been almost 2 months. Hard to believe time flies by. Okay, everyone, please turn on your cameras. Yes, Vyom, Charvi, Ayan, and Darshan. Turn on your cameras, beta. Okay, almost everyone is here. All right. Just one more minute. Um, is anyone left? I'm going to take a picture. Please turn on your cameras. Darshan, Ayan, Charvi, Ayush, Abhinav. Yes, yes. Charvi, Ayan, Darshan. Okay, I think almost everyone is here. Let me take a picture. Okay, so everyone give me a good smile. Yes, give me a nice and big smile. Okay, okay. That was great having a wonderful, wonderful session with all of you, re-interacting with all of you. I think it was great. And if you have any further doubts, feel free to ask them on the groups. Okay. So, all right then. I think this was a great session.